Just going to show you the run out on the end of the shaft right behind the wear where we're going to be doing the build up. And it's half a thousandths, which is where I have this 6-jaw chuck dialed in at. So anytime you can stick a shaft in here and you can get it run within a half a thousandths, it's excellent and usually good enough for most jobs that you're doing. And that's going to work out great right there. This is our 25mm bearing journal that we have undercut ready for our flame spray. Just wanted to talk about this. I didn't get any turning action of this, but I used a threading tool to both undercut it, and then I cut a 28 pitch thread across here. And one of the things I want to highlight is this area right here. This is the deepest part of the groove that was actually worn into the shaft. So it took 45 thousandths to clean this up. And this area, all the way to where I stopped, is only 20 thousandths undersized. So 20 thousandths is typically what I take these things to. So anytime there's a deep groove, I never take the entire undercut the same depth as the groove. Sometimes it's deeper than that. So usually I just clean up the entire journal, and then anywhere where there's a deep groove, I only undercut that short area just to clean it up, and then I try to scratch a thread in there as well, which is what I did. So undercut 20 thou plus the depth of the groove there. 28 pitch is what I scratched across there, about 15 thousandths deep. And now this guy is ready to spray. You can see here's our snap ring groove here. It's not going to affect that. I'll just have to stick a tool in there to knock the overspray out of there. And then once this is turned, all this will be cleaned up and it'll look nice and pretty. All right, so we're set up and we're getting ready to start doing our flame spray. There's a couple things that I wanted to go over before I start. We'll start with the equipment right here. So I'm using, this is a Eutectic Pterodyne 2000 with a rotojet attachment is what I'm using. This just supplies shop air through this valve right here. And I turn this guy on and it's gonna blow out. I got it set at to 30 PSI according to the manual. That works real good, reducing the dust. 21022 powder is what I'm using. And I've got the oxygen settling regulated to the proper settings. The other thing I wanted to mention is that one of the comments that I read often, anytime I share a picture or a video of this process, is people usually say, isn't it bad to be spraying your chuck? Whenever we're filming, it's usually about this perspective right here, this angle, because I'm over there, and of course you don't want to be directly behind it when the flame spray is coming. You're going to get overspray. So when you're looking at it from this angle, people usually think that I'm right up on these chuck jaws, and I'm not. You can see how far away I am out here. The pattern of the spray is going to be right in this area here. It's not over here on the jaws. It just looks like that when you're coming in at an angle like that. It just looks like I'm spraying the chuck, and I'm not. The amount of, you're not even getting overspray on the chuck. What you're getting is a little bit of deflection of the powder, and by the time it gets to the chuck, it's not going to stick it. All you're going to be getting is like this right here. You're just going to be getting dust residue from the fluxes and the mixture of the powder. It's just going to have a little bit of dust on there that you wipe off. There's nothing that's sticking to it. So I'm not doing anything to damage this chuck. I'm also not directing the heat onto the jaws here, and you're not going to, the heat is not going to transfer over into these jaws and damage the heat treatment and the integrity of the jaws or the chuck itself there. It's perfectly safe, it's normal, and there's nothing wrong with spraying next to your chuck. It's perfectly fine. I always use a fire cloth just to kind of prevent any of the overspray bouncing down onto the ways, but I will say that even this is not 100% necessary. Usually you have a little bit of oily residue on your machine ways, and when you're spraying, that stuff, whatever bounces off, is going to just come down here. It's just going to lay on your ways. It's going to stick to that oil. It's not going to bond or weld itself to the machinery ways. It's not going to do that. So you don't have to worry about it damaging your way surfaces. But if you want to play it safe, just put a fire cloth over it and you're going to be perfectly fine. we're looking to hit around 984.4 to 984.7. .984, and I'm reading 4/10 on the 10th line. 984.4. So that bearing journal is good to go. Last operation for the shaft repair is that we have to mill a 10mm keyway. So it's going to be 4 millimeters deep by 63 millimeters long. I'm going to be using this 3/8 carbide end mill right here, and what I'll do is after we make a cut, we'll just offset it to each side to bring it out to the 10mm width. We're going to be using Granddad's Starrett number 700 inside micrometer to measure our keyway. We're looking for 10mm on our width. And of course, we're going to be converting that over to inch measurement. We're looking for 393 thousandths. So it looks like we've got 392 or just under 92. So we're right there at it. That probably could be pretty good. I haven't offset the cutter again, so what I might do is just go ahead and run it down this side that I'm on, climb cut, and just take about another 0.5 thousandths on the DRO, and we'll see if we can open it up just a little bit more. Let's do our checks to see if we hit where we want it. By the way, I was going to say I just use this fine stone, and what I do is I lay it on there to just remove the burr from the end mill, and don't put any kind of pressure on it, but just very lightly. Just remove the burr using a fine stone, and that works real good there. So we'll use our depth mic here. We want 4 millimeters deep. So about 158 thousandths deep. Looks like 158, so I hit my target there. And then we're going to use the Starrett 700 again and see if we can get a reading on the width for our 10mm. Feels good right there. Looks like we hit our target. So we're looking for about 393. So we're just over 393 right there. So that should be a real good fit for a 10mm key. All right, guys, we've got this lathe clutch shaft ready to go. It's all finished up. Got our end there welded up, turned to size. We got our keyway milled in there. We went in and chased the thread, made sure that was good. Polished it up a little bit there to kind of dress up the center. Didn't take any metal off, just polished it. And then of course we got our other end here that we did our flame spray buildup with for our 25mm bearing fit, and then you know, build up that groove that was worn in it from your thrust bearing. So this guy's all finished up. It is ready to go. A lot of work went into that, but it was a good project. I was happy to get Earl fixed up, and so he can get this lathe back in running condition like it should be. We'll get it boxed up and send it back. So hopefully you enjoyed the project as always. Maybe there was a few helpful tips there somewhere that might help some of you guys along the way, or maybe it was just a little entertaining to watch how I repair some of these parts around here like I did for this. So that's it. We'll see you on the next video.